Hello friends, welcome to my channel. In this video, I will cover operation research for gate transportation. Vogel's approximation I will cover. So basic feasible solution exists when summation of all supply equal to summation of all demand. Already discussed, we write in supply in row and in demand we write in column. And basic feasible solution, a feasible solution, sometimes they are writing like this also, BFS. A feasible solution to a transportation problem is said to be a basic feasible solution if it contains no more than m plus n minus 1 non-negative allocations. M is your supply, n is your demand, minus 1 non-negative allocations. And optimal solution, a feasible solution, not necessary basic, that minimizes or maximizes the transport cost or profit is called an optimal solution. And for your non-degenerate basic feasible solution, a basic feasible solution to a matrix m cross n transportation problem is said to be non-degenerate if total number of non-negative allocations is exactly m plus n minus 1. For example, number of independent constant equations or these m plus n minus 1 allocations are in independent position. They should not be in same cell. They should be in separate cells, the allocations. And all non-negative allocation, it should be exactly m plus n minus 1 for non-degenerate basic feasible solution. These theories are also very important. All exams they are asking these theories. Degenerate basic feasible solution, a basic feasible solution in which the total number of non-negative allocations is less than m plus n minus 1 is called as degenerate basic feasible solution. For Vogel's approximation method or VAM method or penalty method, step 1 is calculate the penalty difference between minimum and next minimum in each row and each column. You have to check which cell is having in row and in column. You have to check which cell is having minimum 1 and you have to make the difference between minimum 1 and next minimum 1 in each row and each column. Then circle the largest row difference or column difference. Then step 3, allocate as much as possible in the lowest cost cell of the row or column having a circled row. A circled row is your key row. Then step 4, in case of allocations is made fully to a row or column, ignore that row or column by crossing it. If you allocate fully in a row or column, other cells you can cross. Step 5, revise the difference again and cross out the earlier figure. Go to the step 1. Again from step 1 you have to start. Then in step 6, continue the procedure until all rows and columns have been crossed out. I will solve one example so that you can understand these steps. Question is, find the basic feasible solution of the problem. Problem is given and available, or we can write it as supply. This side demand. Supply is m, demand is n. So first we will check whether basic feasible solution possible or not. So summation of all m, we will write 250 plus 300 plus 400, 950. And summation of all n, all demands we will check 200 plus 225 plus 275 plus 250. it's also 950. So summation of m equal to summation of n. So basic feasible solution possible exists. Here only feasible solution exists, whether it's basic one or not, that we can check later. In step 1, whether solution is feasible or not, that only we will check. Summation of all supply, it should be equal to summation of all demand. So we got here 950, this side also 950. So solution exists. So first we will start in row minimum is in row 1, minimum is 11 and next minimum is 13. So the difference is 2. Here we will write 2. Like this in row 2, minimum is 10 and next minimum is 14. Difference is 4. Here we will write 4. So next row 3, minimum is 10, next minimum is 13, difference is 3. And in column, we will check. In column 1, 11 is the minimum and 16 is the next minimum. So 16 minus 11, it's 5. Here we will write 5. Then here in column 2, 13 is the minimum, 18 is the next minimum. 18 minus 13, 5. Then in column 3, 14 and 13, 13 is the minimum, next minimum is 14. In column 4, 14, 10 and 10, both are minimum. So minimum and next minimum, so their difference is 0. So maximum penalty is here at 5. So this is our key element. So here we will check. So here in key column we will allocate the maximum. In 11 is the minimum. Here 250 and 200. 200 is the demand, 250 is the supply. So we allocate minimum one is 200 here. So we will allocate 200 here. So here in column for column 1, balance is 0. So we can cut 16 and 21. And here for 250 we will write 250 minus 200. Now new supply for row 1 it's 50. So here in column 1, demand is became 0. So we can cross these two. Then again we have to do the step 1. Here again we have to check minimum of, here minimum is in row 1, minimum is 13 and next minimum is 14. So difference is 1. And here 14 and 10, difference is 4. Here difference is 3. Here 13 and 18, difference is 5. Here 14 and 13, 1. Difference is 0. So maximum is 5. So circle it. This is your key. Then here in which cell it's minimum. In key column 13 is minimum. So 13, supply is 50 and demand is 225. So maximum we can supply up to 50. So maximum you supply here 50. So it will become 50 minus 50. It will become 0, new supply. So you can cut these two. And here also 225 minus 50. You will get 175 for column 2 new demand. 175 is the new demand. Then again in rest cells you check the difference between the minimum and next minimum. So here in row 2, row 1 already cancelled. and column 1 also cancelled. So in row 2 you check 10 and 14, difference is 4, and here difference is 3, and here difference is 0, 1, and here 6. So maximum is this one. You circle it and check it whether here 175 is the demand, minimum is 18, this one 175 is the demand and 300 is the supply. So maximum you allocate here 175 you allocate here. In column 2 demand will become 0. So here you can cut this one. Here 300 minus 175, you will get 125 demand supply for the row 2. Again in next step, again in row 2 you check 14 and 10, difference is 4. Here 10 and 13, difference is 3. 10 difference is 0. 13 and 14, difference is 1. Maximum difference is, maximum penalty is here. So this is your key area. Here you check which one is the minimum. Minimum is 10. So 10, 125 is the supply, 250 is the demand. So you can maximum allocate 125. You allocate 125 here. So for 14, 0 allocation left. So you can cross this one. Here allocation left is for column 4, 250 minus 125, you will get 125 for column 4 new demand, and supply here it will become 0 for row 2. Next step, no need to check the difference, directly you can allocate. Here mean demand is 125, here demand is 275. So here it will become 0, here also 0, here also 0. So all supply you allocated to some areas, and all supply you allocated to the demands. So here how many cells? 1, 2, 3, 4 and 5. One more is here, 6. So M is number of rows, it's 3. N is number of columns, M plus N minus 1. 3 plus 4 minus 1, it's coming 6. And number of allocated cells or allocations, it will become 1, 2, 3, like this up to 6. So our solution is non-degenerate. So it's a non-degenerate. Then Z we have to calculate. Z is 200 into 11, here 200, then 11, then plus 50 into 13, plus 175 into 18, plus 275 into 13, plus 125 into 10, plus 125 into 5. Whatever value you will get, that is the minimum transportation cost for this matrix. In problems like GATE, they will ask what is the value of minimum transportation cost using VAM or Vogel's approximation method. So you calculate this value, that answer is your answer. This is the end of Vogel's approximation method. Thank you friends. Thank you for watching my video. Thank you.